We have here three graphs, y equals x squared, y equals x cubed. And this one, just to get something a little more complicated, put 2x cubed plus 3x squared minus 1. And the thing that you're looking at over here is that on the graph, we'll look at y equals x squared first. We have a decreasing slope, and it keeps decreasing until we get to a point over here where the slope is going to change from going down to going up. What we're looking at here is a graph that's generated by Desmos. It's a very powerful tool to use if you don't already have an account with them. I strongly suggest that you get one. It's free. And what you can do is, what I've done here is you click on the three bars in the upper left-hand corner here, and then come down to where it says calculus and you want tangent line right here. Once you click on that and you come up over here, you can put in the function. In this case, I put in x squared. And then I want it to graph a tangent line, and I want to use the x values between -2 and 2. And what it'll do is it'll animate the tangent line going through. And right now we have the tangent line is at x equals -2. And when I plug that into the formula, -2 squared is 4. So I have a positive value of 4. Notice my tangent line has a negative slope. Now, as I push the play button here, as the slope comes down, it reaches our critical point at 0, and then the slope turns positive and comes all the way up to 4. And it'll run it back and forth like that. One of the things that I wanted to point out is where the slope went from negative to positive and it switched over, and then we had a 0 slope at this point. This here point at 0, 0 is called a critical point. And a critical point is when the slope changes from either negative to positive, or it goes from positive, levels out to be a 0. For example, over here on x cubed, it has a positive slope. Then when it gets over here at 0, the slope is 0. So we do have a critical point there. It's a saddle point, and then the slope continues going positive again. So we have positive slope here, a 0 slope here, and a positive slope again here. Let's take a closer look at this one using the first derivative test. So our original function is y equals x squared. Our f prime of x is going to be 2x. And the critical point, to find a critical point, you simply set the first derivative equal to 0. So I have 2x equals 0. And the only way to get that, of course, is if x itself is 0. So my critical point is 0, 0. Now let's say that I have a number line here. And on that number line, 0 is where my critical point is. And we had a negative slope over here, and we had a positive slope over here. And this line is going to go to positive and negative infinity. So in order to test this, if we didn't have the graph, you would be able to input a value, pick something really close to 0, preferably a whole number. So the first derivative being 2x, if I pick values for this, for example, let's say I pick f prime of -1, then I get 2 times -1. My answer is negative, so that tells me that to the left of my critical point, I have a negative slope. That function is decreasing. If I pick f prime of, pick a positive number, so we'll just pick something close, f of 1 would be 2 times 1, which is positive 2. That tells me that the slope is increasing. Now, one thing to note here is if I have a negative slope, then the critical point, and then a positive slope, a negative, which becomes a positive, tells me that I have a local minimum. And if I have a rising slope, then I have my critical point and then a negative, the positive, then going negative tells me I have a local maximum. And here we have the graph of y equals x cubed, and I've programmed Desmos to once again show me the tangent line, and I'm going between x values of -1 to 1. And when I hit the play button, it increases. It's my critical point where the slope is 0, and then it begins to increase again. Coming back, notice that to the right of the critical point, it's rising, the slope is increasing, and to the left of the critical point, the slope is increasing. Our original equation is y equals x cubed. Then to perform the first derivative test, I take the first derivative of the function, which is 3x squared. I set that equal to 0. And the only way to get 0 is if x is 0. So far with my critical point, I know the x coordinate is 0. Now I take that 0 and I go back to the original equation. I put a 0 in here, and the y coordinate is also a 0. Looking at a number line, I know my critical point is 0. And I want to know what happens to the left and to the right of the slope being 0. And that'll tell me if it's an increasing or decreasing function. So I'm just going to pick -1 and 1, really close, whole numbers, easy to work with. If I put in a 1 here, I get 3 for the slope, it's positive. And over here, if I put in a -1, well, 1 squared is 1 times 3 is also. So what this tells me is my function is increasing. My function is increasing as I approach the critical point, and then after the critical point, the function is again increasing. Here looking at Desmos for the equation 2x cubed plus 3x squared minus 1. I have the tangent line set up, and it's going to run between x values of -1.75 and positive 0.75. So we'll see that as the tangent line is moving, we see it's increasing until it comes to a critical point, then decreasing until it comes to the next critical point, and then it continues to increase. This here point, while it is a maximum, it's only a relative maximum on an interval between two x points. If I was really close between here and here, it's a maximum. But as you can see, the function goes up into positive infinity, and on the left side it goes negative infinity. So the x values that we've found where the slope is 0, giving us critical points, that's only a relative maximum and a relative minimum. The original function is 2x cubed plus 3x squared minus 1. The first derivative is 6x squared plus 6x. To find the critical points where the slope is 0, I set the first derivative equal to 0. I need to factor this side. I can remove a 6x. So the two places for my critical points, there's going to be two of them, is when x is 0 for this one and when x is -1. When x is 0, I go back to the original equation, I put that in, x is 0, this is a 0, this is a 0, and leaves me with my y is -1. So I have 0 comma -1 is one critical point. And then the other, to make this entire thing equal to 0, this would have to be a -1. My y value is 0. So these are my two critical points. Let's look on a number line to see what happens to either side. On the number line, I have put the x values for the critical points. This can run out to minus infinity and positive infinity. I just want to know if the function is increasing or decreasing. That's part of the first derivative test. So putting in the value of -1 into the derivative here. So at -1, the slope is 0. How about just to the left of it? So what I'm going to do is I'll put in a -2. So using a -2 on this side, it's positive, so the function is increasing, and you can see that here. Now I need a number between -1 and 0, so I'll pick minus 0.5. So between 0 and 1, this function is decreasing because this is negative for the first derivative. And you see that decrease here. So for the last part of the graph, to the right of this critical point, from here to here, we want to see if it's increasing or decreasing for the slope. So we're looking at the first derivative with a 1 substituted. So this is positive, so we can see for the final part of the graph that it's increasing